Hello everyone, and welcome to the universe we live in. My name's Rick Costello, and I'm be teaching you about how stars are formed today. And the last show we talked about where stars are formed in these nebulas. And this show we're going to talk about actually how stars are formed. And here, of course, we got our planet, the sun here. And our sun gives us warmth. We need the sun. It gives us life on the planet. It makes the planet a livable planet. And we need our sun, and it's if our star was the only star in the whole universe, we wouldn't be able to see the other universe. It's luckily because stars are formed that we're able to see the universe. It lights up the universe, lights up our galaxy, and we can see our galaxy. And as we look out into the galaxy, here we are with our galaxy, the Milky Way band, with our 200 billion stars plus. In our galaxy alone, could be even more than that. Our galaxy seems to get larger the more we're able to see it. And so there's a look at our galaxy here. Now as we look out into the galaxy, on this next photo, we have these two galaxies here, M81 and M82, two of my favorite galaxies to look at through my telescope. Very cool galaxies to see. And these galaxies are about 12 million light years away from us. And because of the stars, because they light up the galaxies, as I was saying, we can see these galaxies. And these are pretty cool galaxies. Now, this next one is the Whirlpool Galaxy. And this galaxy is about 12 million light years away from us. And it's a giant whirlpool. It's about 76,000 light years across, compared to ours, which is over 100,000 light years across. But it's only got the mass of about 10% of our Milky Way mass. And so you can see these clouds here, all these reddish areas and the bright areas in the spiral arms. That's where the stars are forming, these bright areas. And if I back up here, you see the second galaxy, which is actually behind it. And we think the second galaxy is what caused these spiral arms and the starbursts. We think this galaxy actually came through the whirlpool and then went back. Gravity pulled it back right through the galaxy, right through the Whirlpool Galaxy, and that causes the spiral arms and the shock waves that cause the spiral arms, and the star formation begins there. Now this next slide is a bar spiral. Our galaxy is a bar. You see this bar in the middle here. That's why they call it a bar spiral. And again, you can see all these lit up lines here. Those are all star-forming clouds where new stars are being formed, which usually happens in the spiral arms, especially in these galaxies. And then as we look out, the stars allow us to see the universe. And we can look at other galaxies into the universe, and that's what light is great for, these stars lightening up the universe. They allow us to see the universe. And now in this next slide, the light from these stars light up these galaxies, and we're able to see galaxies billions of light years away from us. And now we can actually look further, and here we are looking at the Hubble Ultra Deep Field. And these stars, since they light up the galaxies, they allow us to see these galaxies back to when the universe was only a few hundred million years old. These galaxies, the farthest galaxies we can see, which are pretty small in this picture here, but they're very dim red galaxies. They're over 13 billion light years away from us, the farthest galaxies we can see. And as we look at galaxies, at this 13 billion year mark, and then we look at galaxies closer and closer, we can actually watch the universe age. And now this is where stars are formed, like we said in the last show we talked about. And this is the Orion Nebula, a giant gas cloud. It's about 26 light years across. And inside this cloud, we know of about 700 stars that are being formed. Could be more, but we know there's at least 700 being formed right now. And this is where they start. And we're going to go up here on this. The next one's going to be a close-up of this dark band here. There it is there. A really thick cloud of gases and dust, mostly hydrogen. I mean, hydrogen was the first element to be formed in the early universe, with a little bit of helium also. But this cloud, because of supernovas that that fused all the higher elements up to uranium, and they blow them out into space. So this cloud is actually full of supernova remnants, and over time, this is going to form more stars. But now you have the elements also to make planets, the rocky planets. You have the silicone and the iron and all the heavy elements made in supernova. And then this is the Witch Head Nebula, very cool nebula, and again a star-forming cloud. And now on this next one, we're gonna, this is a thick cloud of atoms here, really thick, and this is where the stars are really being formed here. These clouds are really thick, a lot of star forming going on, and these clouds that are all lit up by newborn stars. And as we move on to the next slide, here's the supernova. Now, with these nebulas, what they need is a shock wave of some kind to start getting a circular motion inside the clouds. And when a star blows up, it sends out the shock wave. And if there's a nebula near it, the shock wave will push the gases and dust in that nebula. And almost like a campfire, if there's a lot of smoke in the fire, if you blow on it slowly, you notice these little ripples start whipping around. You get some circular motions. That's kind of what's happening inside these clouds. The shock wave hits the cloud, and you start getting these little twirls where the matter starts spinning around, rotating, and it starts collapsing on itself, and that's what forms the stars. All right, and here we have an artist's rendition of a solar system being formed, and you can see how the matter in it is swirling around the disk. The protostar would be right here. This disk is rotating around it, and as it does, it's pulling in more and more matter, and over time, this protostar is going to get larger and larger. And it takes like 10,000 to 100,000 years. This knot's going to get denser, and it's going to grow. It's going to warm up, and it's going to begin to glow from the heat being generated by matter falling into the core, into the star as it heats up as it gets older. And on this next slide, he would show some some more of the winding going on, the collecting dust here. And now this is going to go on for another 100,000 to 300,000 years. And after that time, the core is going to grow really warm, and it's going to start. The heat is going to start pushing matter away from the core, and over time, that matter will stop falling into the core, and the core is going to stop growing at some point. But as it does this, the outer reaches here, they begin to cool. And what you can have there is it cools enough for planets to form. Like on this next photo here, is this gas cloud here. Now there's two things that can happen with this gas cloud as it orbits the protostar, the star that's being formed in here. And this gas cloud, it can either collapse into maybe a gas giant planet, or if it's got enough mass, it could actually grow into another star, and you end up with a binary star system where two stars have they're gravitationally attracted to each other. And so you can have double stars or triple stars too in some of these things. Some of these things can grow 2 or 3 stars if they have enough mass. But if not, maybe even a planet on this last slide. And so here we have a solar system forming. This is an artist's illustration here. And you see the rotation going on, all the matter swirling around that protostar, that growing star. And a lot of that matter falling into the star, making it grow larger. But also you see these gas clouds, those bright spots moving around it. And those may condense later on into planets, or as I said before, if there's enough mass, they'll go into stars. And so this is kind of the way this will go on for hundreds of thousands of years as a star forms. And on this next slide, this is an actual solar system taken from NASA. It's actually a solar system being formed. And you can see all these dark rings around it. And those are the planets that are being formed. And as they go around the sun here, they're actually accumulating all the matter in their orbit, and they're clearing out. And that's what these dark lines are. It's basically the planets clearing out the gases and dust around it and growing larger as they do. All right, here we have an image of a star, a red dwarf star in this case, a smaller star. And the core here is where the action's happening. And you got to think of these stars. I mean, some of these are, tens of thousands or of miles in diameter, hundreds of thousands of miles in diameter. And the weight at the core of that atmosphere crushing, almost like, if you think about being in the ocean, if you were like, say, the deepest part of the ocean, 7 miles down from the surface, if you were down there, the weight of that water is just going to crush you because it's so heavy on top of you. And the same thing's happening at the core. The weight of all that, of the atmosphere above the core is crushing the core, just crushing it. And the atoms inside that are basically moving really fast as they heat up. And they get to a point where they're moving so fast when the temperature reaches about 15 million degrees in the core, the process of nuclear fusion begins. And what's happening there is you have atoms, and they're traveling so fast, and they basically slam into each other. And when they do, the strong nuclear force, when they get close enough, the strong nuclear force brings them in together and fuses those atoms together, and then you get the heavier elements. And on here is this is what's happening inside the core. And this looks a little difficult, but if you notice, this side here is the same as the other side, and then they meet down here. So we'll just start with this side over here. And on top, you have the 2 protons in the red there, and they're going to fuse together, and they're going to release, as you see here, they're going to release a neutrino and also a positron, which is the opposite of an electron. It's a positive charged electron. The antiparticle of the electron. And so what you're left here, after that happens, is you're left with 1 proton and 1 neutron. And then you go over here and you add a third one. And when those join together, it releases a gamma ray, and that's light. And it starts out as a gamma ray, and by the time it reaches the surface of the star, which could be tens of thousands of years to leave the core and finally reach the surface, it comes out as visible light, and plus other lights too that we can see, but visible light, and that's what lights up our sky. And so after that happens, down here you end up with 2 protons and 1 neutron. And the same thing going on in this column here. You end up with 2 protons and 1 neutron. And then one more time they fuse together here, and they throw out 2 protons, and what you're left here is 2 protons and 2 neutrons, and that is a helium atom. Helium, of course, 2 protons, hydrogen with 1 proton. And again, the number of protons determines which element it is. You just add more neutrons. 3 neutrons is going to be lithium, then 4 is going to be beryllium, 6 is carbon, 8 is going to be oxygen, 26 protons for iron, and then you get all the way up to uranium with 92 protons. And so the number of protons determines which element it is. And so here we have a photograph of some solar systems being formed in Orion. Again, I said, we know of about 700 stars being formed in Orion. But here we have actually solar systems being formed. You can see the glowing stars in the center of these, and then the disk of material around it. And that's going to eventually, maybe form planets in the future, and maybe still making the star a little bit larger in some mass. And this is how stars are grown in these nebulas, these clouds. And I should mention, like our sun is fusing, hydrogen into helium, and it's doing it at a rate of about 600 million tons per second. And it's been doing that for billions of years, and it's going to continue for another 4 billion years or so before the sun has ended its life, or probably another 3 or 4 billion years. And on this next slide here, we have another one. These are some close-ups of a new solar system. These are very cool when you think, and these solar systems are actually larger than our solar system. These are very huge things. And again, you probably have planets growing in that disk here. And then we got another one coming up here. I'll show you. There's a little brighter star in this one, probably more advanced in its evolution. And again, you can see the dust cloud around it, and probably planets forming in this cloud, as well as this next photo, as another solar system being formed. And so we're not the only solar system out there. We're realizing that most of the stars we see when we look up at the sky have planets. I mean, planets are pretty common in the universe, in our galaxy, and most likely the universe in other galaxies. And here we are, an artist's rendition of a gas cloud. And you see the thick clouds and the star forming in the center, and all is rotating around the star, and probably forming planets in this, if this was real, this photograph here. And here we go as a solar system. This shows us the system thinning out, and the planets circling around it and carving out their paths around the star. And so this is how a solar system forms. And over time, the solar winds are going to blow this dust away, and eventually there'll be no more dust to make the planets any larger. But at this point, they're still orbiting in this nebula of gases and dust, and they're growing as they go around. And here we are back to stars. Like I said, if it were for stars, we wouldn't be able to see the rest of the universe. And luckily, there's stars out there, so we can see. Here we have a globular cluster with hundreds of thousands of stars in it. A beautiful thing to look at through a telescope is a bunch of these that I was looking at a few nights ago. They're all situated near the center of the galaxy in that direction. And this time of year, the center of the galaxy, about 11 o'clock at night, maybe 11:30, is right due south, and the Milky Way band going right overhead. This next slide, more stars. Luckily this stars are shining so we can see them, and then gases and the nebulas and all there. And the stars come in all different colors and sizes, from very small stars that are maybe 8% of the mass of the star of our sun. And they can go all the way up to maybe 200 times the mass of the star. In the earlier universe, might have even 300 solar masses for sizes. So some of these stars can get very huge. And here we go, another star field. I mean, just in our galaxy, so many stars. And you have these red cooler stars and the bluish white stars. Those are the hottest stars, burning the hottest. And here we are back to our Milky Way galaxy. This is our scene here. And this is like over our night sky. And we can see in the northern hemisphere, we can see from about maybe right here and then north. This is basically the Milky Way band going over us right now. And we have, of course, the center of the galaxies right about there. And if I move over here, we have this star right there. That is the Proxima Centauri system, the Alpha Centauri system, where Proxima Centauri, the closest star to us, resides. And that's where that is. So that's our Milky Way band. Just lots of stars lighting it up for us to see. And you can see this thick gas clouds in our galaxy. A lot of stars still being formed in our galaxy, as will happen for billions of years to come. And I'm going to leave you with this painting, this picture here. This is actually one of my paintings of the galaxy. They're astronomically correct. All the craters are on the moon in the right place, and the stars in the galaxy are all in their right place. And this is kind of what I do on my side, paint pictures of our galaxy. And this is one of them here. And so that's how stars are formed in these nebulas. And on the next show, I was going to get into individual stars, the small stars, the mid-mass stars, and the large stars. But we'll get that in a couple of weeks from now. But I think the next show, I'm going to lighten up a bit, and I'm going to show you basically things that are in the sky to see. I'll show you the night sky, and then we'll zoom in on some different objects, galaxies and nebulas, and I'll show you things that are up in the night sky to see. So I hope you join us for then. And I'd like to thank Michael Sinopoli for producing this as always. And my name is Rick Costello, and welcome to the universe we live in. And whenever you get a chance, look up. Thanks for joining me. We'll see you next time.
Oh.